time to make these presentations. There'll be two this week, one today, and the other is actually Thursday, right, Stan? You have 19th up there on the slide, but that'll be the 20th.
20th, that's correct. Should be 18th.
And we'll be recording these for folks who aren't able to attend in person. We appreciate all the folks out there across the 49 states, I guess, plus Puerto Rico, are all in the domain now of the Rapid Refresh. Again, the standard go-to webinar rules apply. Remember to keep your phone muted unless you need to ask a question. And please don't put us on hold because we'll get your weather radio, and that sort of disrupts everything. So if you need to drop off, take a call, come back on, that's perfectly fine. Again, I want to thank everybody for joining us today, and particularly the folks at GSD, and you can see is really a cast of many that all contributed to the Rapid Refresh model. The decision has been made. It is scheduled to be implemented next week. So we thought all the SSDs together decided it would be good to have these webinars to sort of introduce you to some of the new features, the benefits that we'll be seeing from this version of the Rapid Refresh model. So Stan, it's all yours.
Thank you. We really appreciate the involvement with the Weather Service folks, you guys who've made comments as we went up to the implementation of the Rapid Refresh 20 months ago, and now with this one also with our shortcomings in Rapid Refresh version 1 that helped us a lot in getting to this point here for Rapid Refresh version 2. So I am going to give a rundown of what's taking place here with these changes in the data assimilation and the model, and also look at a number of case studies here. So I want to thank especially Jeff Manikin and Curtis Alexander and Steve Wigan have a key role, but so has many of the other folks here on this diagram. So the Rapid Refresh, you guys know all this. We have the hourly use by you all in the Weather Service, but the FAA, private sector, and actually the energy sector is part of that, playing a key role in that. And then we're looking ahead to the HER implementation scheduled for July, but we'll save that for another talk in a few months for you all for a briefing on the HER coming in, what that will be. So in the Rapid Refresh version 2, we do have these improvements in the model and the analysis also, and I think you guys are aware of these resolution. It's a 13 kilometer 50 level version. We do bring in GFS data twice daily and run a 6-hour spin up from the GFS, so that helps us for the long waves to be able to be captured well in the Rapid Refresh. And then we have the output grids here. There are a lot of dependencies downstream, so NCEP had to go through all these your use, but obviously the first guess for the RTMA, the initial condition for the SREF members, so that's getting changed. In fact, both the RTMA and the SREF will change a little bit with this implementation a week from today. And obviously the RAP is really critical in initializing the HER. The primary part of the HER initial conditions are from the RAP. The HRW runs actually also benefit from the RAP update. So the whole point we're doing the Rapid Refresh, I think you all know this, is that we bring in the latest observations and we can get a smaller error. So this is looking at errors in wind forecasts here as we have the vertical dependency here and pressure going up, and then the accuracy, the error is low as we go to closer and closer forecasts. And that's been true pretty much at all levels, especially for winds, but also true for temperature and relative humidity. So that really is sort of, this is our signature diagram here, just to, if we make changes and we don't maintain this kind of dependency and having more accurate forecasts going to shorter range, then we're not doing our job. So you can see that that is taking place here. Observations that are being used in the Rapid Refresh. I guess a couple changes here. One is that the lightning data is coming in as a proxy reflectivity information from the NLDN. There is an effort in the Weather Service to get the new VISOLA Global GLD 360 data in, but that won't happen with this implementation. And then also, we had not been using the satellite cloud information for building in Rapid Refresh version 1, but now we actually are doing that at least for low-level clouds when clouds are within 1,200 meters of the ground level here. So that definitely improves the low-level cloud forecast when you have some kind of stratus situation. So this slide here is kind of a summary of the enhancements in RAP v2 over RAP v1. So this first set of boxes in this table here is regarding the data simulation. The second one is regarding the model. So I'm going to give you some more details in this as we go through here, but the simulation type, we're using a 3D bar, so it's sort of a fixed background error covariance and how the observations affect the produced analysis of the increment. And that's changing following what took place with the GFS, and that we're able to use the GFS ensemble here to have this weather adaptive structure of the background error covariance. So that is part of what's going in. I have another slide on that later. And then we also are using a temperature dependency in how we actually specify hydrometeors from the radar data. That's pretty critical for having the more accurate 1 hour precipitation forecast in the summertime. We also are bringing in surface observations, and we're allowing them for moisture only to produce pseudo observations. That's a key part. We have adjustment to the soil moisture and temperature, another slide on that, and then the slow cloud building. So these are the sort of the summary of the key changes that are taking place within the GSI. Now outside of that, we also use this daily snow analysis from the Snow and Ice Center. And so we have revised the way in which we're doing the trimming from that of the snow-covered areas. This is pretty critical for if you're close to that edge of snow cover versus not, and then also having building of the snow cover. So this really reflects the daily snow analysis much better in RAP v2. Radar data, or the lightning data, going here as well. And regarding the model, we have a couple years update from the ARW version that's going in here. Switch over to the land use. We went to this more recent Lotus data set. It's a global data set, and we can actually use that in a fractional basis to get combine different smaller scale land uses within a given 13 kilometers square to be able to get the best estimate of roughness, length, and albedo, and so on and so forth. Going to a 9-level land surface model, slide that coming up, and a different MYN, a different PBL scheme here, which we think is, in fact, we know is better for stable conditions, and updated from the NCAR, Greg Thompson, microphysics. So just to summarize here, just to get the basic ideas, this is your take home. We do have this hybrid data ensemble data simulations coming with RAP v2. That's a big deal. And then our use of the soil adjustment and the boundary layer, using observations even through the boundary layer and the cloud. This aspect of the simulation really helps a lot in getting a better boundary layer environment for the RAP refresh version 2. That has consequences both for the RAP but also for the HER downstream. And then these improvements in the physics for the land surface, PBL, and cloud for the model. Let me just stop there. Is everybody okay on track here so far? Okay, I'll keep hopping on here, but feel free to interrupt. We can make this interactive as you guys would like. So thanks again for dialing in. So this is kind of a summary slide here on the forecast accuracy. So we're seeing an improvement here in winds, both upper air and surface. The wind actually is an example here. This is looking over, I think here, this is about a 2 or 3 month recent period here. This is looking at accuracy of vector air against ray obs. So here it is, September versus November, right through our shutdown period. But the models kept running. So this is showing here that the forecast errors for these, I believe this is a 6-hour forecast, are better at pretty much at all levels here. And this is showing the difference by which it is better. So that's been a consistent improvement in the moisture forecast aloft. And I'll show you some results in subsequent slides in the surface. Temperature is better, and I would say this is a stronger area in the precipitation in the cloud forecast. Precipitation especially, maybe a slight improvement here for ceiling. So this slide here, I'm going to actually focus first of all on each one of these areas. I've already mentioned them, but show you a few slides on these data assimilation improvements. So that's what we're going to now take a look at next. First of all, the use of this hybrid data assimilation. As you guys all know, back in May 2012, on the 22nd, in fact, 3 weeks after the Rapid Refresh version 1 implementation, this big GFS change went in, really significant for NCEP in that the ensemble data assimilation was introduced with an 80-member ensemble for the data assimilation. Well, it turns out NCEP wisely saw that that could be used also for the regional model data assimilation. So we talked with the folks there who were actually already testing this for the NAM. And so we were able to follow that and make some very quick progress in that. So that now this three-dimensional covariance structure, which is weather adaptive, then is being used in the data assimilation now in RAP-V2. So the observations have a kind of an anisotropy in its structure in a helpful way. And actually that's been responsible for a lot of the improvements in the wind especially, but otherwise. So this HM here stands for the hydrometeor. This is really coming in from the radar and from the satellite and METAR data. So there's an update to the hydrometeors, and then we do continue to do this digital filter to produce the final initial conditions for the RAP. And so these parts are similar, but what's new in RAP-V2 is the way in which we use this ensemble covariance from the GFS to get a better weather adaptive data assimilation in RAP-V2. So this is actually looking at some improvements, and this is actually sort of a controlled set of experiments a little over a year ago that we did looking at the improvement coming from the hybrid ensemble data assimilation. So the wind shows a big improvement. This is errors against RAOBS here again. This is 3-hour and 12-hour forecast. A smaller, but some improvement definitely in the relative humidity, not so much near the ground, but definitely in the middle troposphere. And temperature, again, a modest improvement there as well. So thank you for drawing my attention to that. Okay. So again, improvements here in all three of these areas from the hybrid data assimilation. I'm going to watch the screen here also to see. This is kind of a summary of improvements that have been going in. This is our reflecting on the lower left here, this forward-backward digital filter assimilation. It's actually being done about the same way here now, although the way in which we use have this temperature dependence is now a little bit different here. This is actually kind of a recap here on our use of the satellite and also the METAR data assimilation to modify the three-dimensional structure of the hydrometeors. And so that is where we're using the satellite data to specify for these cloud decks that are within 1,200 meters from the ground. And this slide over here is just mentioning about how we do use these pseudo-observations from the surface dew point obs to force a structure that's appropriate to the boundary layer. So the next slide here shows an example of this better boundary layer structure of the dew point, and I'm waiting for it to come up on the go-to meeting. There we go. So this is actually a reflection of from the SPC, who actually looked at this. They were noticing this also, the problem in the Memphis sounding, analyzed sounding with non-realistic structure here. This is actually just from a couple of months ago. And then with RAP-V2, seeing this more well-mixed boundary layer structure. And this is a consequence of using this pseudo-observations of the boundary layer. So that's really critical for the RAP. It's also critical for the HRR. And in this particular slide, more realistic case for this situation, which did have some severe weather. So in the next slide here, here's our kind of focusing on our key areas where that occurred. This now, next slide here looks at these improvements in the snow updating from the IMS Snow and Ice Data Center. So on the left here was the snow cover from the RAP V1 before we were doing this. This is actually an SREL version, but reflecting the same so we have improved trimming now. There was some temperature dependency that was resulting in, I guess, poor trimming of snow cover. And so we removed that and then also added a building of about a few millimeters here of water equivalent of snow in a situation where we had to do that. So not enough to be able to maintain the snow cover for too long a period, but certainly to keep it through, well into the next day, especially if the temperature is below freezing. The next example here is one from Jeff Manikin, which shows an example that he pulled off from his inner comparison, and that reflects from this last winter here, much improved snow cover, and the parallel to the bottom one here is from the RAP V2 and showing a much better snow cover, and on the left here looks uses for a comparison of the no-risk snow analysis information for the snow cover. So a big improvement in that area, and that makes a big improvement in our the RAP boundary layer temperatures in certain situations. Another aspect of the lower boundary conditions that has been improved is that in RAP V2 we're using an improved lake surface temperature field, and this is about to come up here. So we were using some information. Some of you may have seen the NAM has been a little challenged here in the Great Lakes areas. So the RAP V2 did switch to the global SST analysis for the Great Lakes, and that seemed to be an improvement there. But it switched also to the NAM, which we were not using before, for the smaller lakes in the western U.S., and that actually has been an improvement there. So it's not to I guess, criticize here just the NAM. It seems like we were able to get the correct combination here. So seeing a much better improvement in the lake surface temperatures for the Great Lakes in RAP V2. And then, in addition, I mentioned before about this adjustment to the soil temperature and moisture. So we're able to use the announced increments for the temperature and moisture field. I'm sorry, this is taking a long to come up here. But in the daytime, if we don't have precipitation, as many of you are aware that when you see these temperature and dew point areas, let's say the RAP is running too hot and too dry in dew point, then you can infer that there's some kind of soil moisture error in that. So we actually have introduced here an adjustment in the first couple levels of the soil model here to be able to make these modifications, and also corresponding if there's a cooling and warming of the soil temperature. So that is another critical aspect in keeping the soil temperature and moisture field in check through this data assimilation connection with the atmosphere. Lastly, as I mentioned before, out of the lightning density rate per unit area, it's possible then to infer radar reflectivity over these coastal areas and actually over the Intermountain West. And so this is just showing the example here in which this extension of the squall line is appropriate down over the Gulf of Mexico that was allowed by using the data assimilation. Okay. Let me stop again here. Any questions on what we've now done so far and talked about? Okay. Interrupt again as you see fit. So now we're going to switch over to the model aspect. Sorry to interrupt. Go ahead. Sure. How is the soil moisture and soil temperature? How are they improved? So what happens here is that the soil moisture content and the temperature during the daytime, there is actually an adjustment. This is within the GSI data assimilation that we're all at NCEP using. And this is a new feature developed for the rapid refresh. So I guess the example I gave would be a good one. Let's say the 1 hour forecast from the rapid refresh was running too warm and too dry. And that would be after we bring in, the latest METARs and other surface obs. So if you have that condition of the opposite sign of the temperature and the moisture change that the atmosphere is trying to do near the surface, then out of that, then we infer that we should try to make an adjustment to the soil moisture and temperature. And the opposite may be true also. Let's say the raft was too cool and too wet versus the METAR ops, then we would want to dry out the soil moisture. So that's the basic idea. Does that make sense? Yes, thank you. Yeah, thanks for asking. Okay, so we're now switching over to the right side of the screen and going to give you guys a quick update on what's taking place in the improvements in the model for RAP-V2. So one of these aspects is switching to a different boundary layer scheme that seems to, in fact, it does do a better job in stable conditions here. And so this is still, it's not dissimilar. It's a turbulent kinetic energy-based scheme, does local mixing like the Mele-Yamada-Yánich scheme, which the RAP was using before, but with improvements in what takes place near the ground especially. And our colleague Joe Olson has done a lot of this work here. So the next slide is just going to show a difference here in the TKE in the boundary layer, and it'll come up here in just a second compared to the previous MYJ scheme. For those of you who have used MYNN with the WRF model before, Joe has been doing some significant improvements. They got it at 3.41, and actually 3.51 probably is the best version yet here. And I believe if any of you use WRF model, the 3.5 version will have the MYNN version that is being used in RAP-V2. So I'm still waiting for a change to take place here, and it's Bernard, there we are, finding the feedback. So this is looking at TKE in a boundary layer. It happens to be from a mountain wave situation here from a few years ago. But so an improvement here, we think in the TKE in the boundary layer. Curiously, this is more of an unstable case in this situation. And with the modifications, there was an error that if any of you ever use SUS out there playing with WRF, trying MYNN, some spurious things would happen with the mixing length with the original version, and those have been repaired. So the 3.5 version of WRF is pretty good now with MYNN, and that would be comparable to what we're using in RAP-V2. So another aspect in the physics that has been modified is that the 6-level land surface model that the RAP was using before has been switched to a 9-level version, and that gives thinner layers near the ground, and that allows us to be able to have a better diurnal cycle near the surface. And so that was quite evident in doing verification on that. So you can see here that previously the second level was down at 5 centimeters, and now there are new levels at 1 and 4 centimeters, and then a little higher resolution here. And again, that's an improvement for the diurnal cycle, and then in turn the boundary layer structure and even storm environment during the warm season. One other aspect in improvement in the physics had to do sort of a bug that was discovered. We heard about this from NCAR. It's not to come up here, but it has to do with the snow attenuation in the radiation scheme used in the RAP-V1. And so we already knew that this could be an issue, and forgive me again for this taking so long here. Bernard, this is pretty nasty here with a 15 to 20 second delay on slides coming up. I'll try to shift my talking here ahead, but this is actually looking at one of a key bust case here in the RAP-V1 for the snow case over North Carolina just about a year ago, actually. And so it turned out that we were able to trace this to the an error in the radiation. This actually is looking at this lower part here of the radiation that was getting through. So much more attenuation in the RAP-V2 in which this snow attenuation was fixed here. So it's a simple thing, but I've got some more examples that are coming up here. In fact, I'll switch to one right now, which is from the first Atlanta snow event, not the second one. This is the one the week before the AMS meeting, in which the RAP actually was holding on to temperatures well above freezing, around 40 Fahrenheit, 3 to 4, at least upper 30s anyway, versus what really happened when keeping it a little bit below freezing here. And so there probably were a few things playing in, but we believe the snow attenuation in the short wave was a factor here also. And then there's one other similar case that our colleague Jeff Manikin at NSEP put together, and this is again looking at a nighttime difference here, but much colder temperatures showing up that were more accurate from the RAP version 2 here. So again, this is probably due to improvement in hydrometeor assimilation from the radar, because we're using the radar to specify snow. So the snow cover is better both from the physics, also from the use of the IMS, but also in addition to that, the improved radiation for snow in the air. Okay, and then sort of putting this together in some verification near the surface. This is actually now focusing in on improvements that were solely from the boundary layer scheme and from the 9-level land surface model. And so seeing improvements here aloft, actually in the lowest 100 millibars or so in temperature and relative humidity. So those are exactly what we wanted to see, and did see that. An improvement in the 10-meter wind bias. So the RAP V1 has been pretty zippy with the 10-meter winds, especially at nighttime here, but even the daytime as well. So seeing a significant improvement. And this actually, right here in this lower left slide, this is the biggest driver for going to the MYNN scheme here, but it has an impact overall on the rest of the PBL development. Also, this improvement in the 2-meter temperature bias, again, staying closer to 0 here and having these extremes for the errors in the diurnal cycle, that was probably a consequence, especially from the 9-level land surface model. Okay, and then going to a little bit more verification here. This is actually looking at this last fall and seeing improvements in the top row here is for RMS errors for 2-meter temperature and dew point. So especially in the nighttime, a big improvement in the temperatures from RAP V2, the blue line here. A smaller improvement, but some there also in the daytime. So this is kind of normalized by hour of day for these 6-hour forecasts. And then the dew point also being quite a bit better in the RMS differences overall, almost all through the day. For the temperature bias, there was a warm bias. That is not completely removed from RAP V2, but much better in the nighttime, and then about the same for the bias in the daytime. For the dew point, a much improved bias here, had a moist bias through much of the day. There is an indication here that overall the bias seems to be possibly worse in the dry side. What we think is happening here is that we had in the daytime the accuracy of the dew point forecast is actually better in the moist areas, but it remains to be too dry in the dry areas. So the net bias now looks to be like we're running dry overall, but if you compare that with what's taking place in the upper right here, we think that this actually is a step forward here. So there is continued work here toward RAP V3, which will come up in the end to further improve this situation. But overall in the net, we would say this is a pickup both for temperature and dew point forecast from RAP V2. An example here from Jeff Manikin, a case from last summer in August, which is slowly coming up, in which kind of a classic example of the warm bias in the daytime. So these are forecasts of RAP V1 and RAP V2 in the left side here, compared to the observations in the middle. And so differences here, the temperatures actually were, and I think that I kind of lost some of the color tables, but running up to 110 here or so in RAP V1. And so those are more reasonable in the lower 100s over North Texas there. Over, you can see a big difference here over northern Kansas going into Nebraska, where the temperature should have been down in the upper 80s here kind of range, and so a better forecast in RAP V2, which is somewhat better predicting that. So a nice improvement in this particular case. Another variable to look at here is the wind forecast. So this is looking in the upper left here, the RMS air per 10-meter winds at the surface. So just a nice improvement overall at pretty much all times of day, and the bias is improved also, especially at night. We're going to actually see some quite bigger yet improvements in RAP-V3 next year, but again, save that for another story. But seeing some improvement definitely in RAP-V2 here for 10-meter winds. Also looking at precipitation forecasts for critical success index, an improvement in RAP-V2, so higher is better for this score here at all of these thresholds, and then the bias also is improved with closer to an even bias here of 1. This is from comparisons done over one period for last fall. I guess we've got another one coming up here for the winter period, ending just a little over a week ago here. Again, the CSI looking better for RAP-V2 at all different thresholds. This is for 12-hour forecast periods, and then the bias being better. So this is a pretty good outcome here for precip. So we have a couple of case studies to look at here. Steve Wygant put these together for the EMS meeting. And so a first example here, looking from a case in November, in which this break between these areas of heavy precipitation back close to Piedmont region, you're going up into the mid-Atlantic states here versus the coastal precipitation. So it's much better captured here by the RAP-V2, seeing that gap between, again, the western area of heavier precip versus the coastal heavy precipitation showing up in this case. The objective verification was clearly better in this case also. And now I try to go to this next slide, which shows that this is now looking at verification. Slowly it will come up here. There we go. So this is actually using some color coding here versus the observed stage 4 precipitation here. And so the greens mean what you think they ought to mean. Those are hits. This is here now for the 2-inch threshold. This is a heavy precip case here from this day last November. And so the reds are looking at the false alarm areas. So seeing a much better improvement, much more green, less red. That's good from this case study from RAP-V2. So the next case here is just to look at an example from ceiling forecasts and aviation flight rules. So that again is slowly coming up, but seeing an improvement in the ceiling height and coverage overall. And again, I'm killing time here as we wait for it. There we go. So this is now comparing on the lower row here, RAP-V1 versus V2 versus the observations. And so this is really dominated here by ceiling rather than visibility. But you can see there really wasn't much flight rules being applied here in the upper Midwest. Much better capturing of that, not perfect, but much better from RAP-V2. And then in these areas to the south here, for instance, on the coast area is the oval show here, really no cloud cover over the eastern Carolinas here, and a much better forecast in that. The next slide is showing some objective characterization of the 1,000-foot ceiling 6-hour forecast in RAP-V1 versus V2. And so what we see here overall is that an improvement in skill overall in the total skill score. And if we look at the bias, this really turns out this was what tells the story. We just had over forecasting a lot more of that with RAP-V1. And with RAP-V2, we have less over forecasting, but we're still capturing the areas where we're getting the IFR conditions. So an improvement there to that forecast. For 3,000-foot ceiling, I don't have a slide here, but you might find interesting that the RAP-V2 improves the 3,000-foot ceiling, the MVFR, in the summertime especially. That's a big pickup there. And so overall improvements in the ceiling forecast. So now we go to a case study here with just taking a look at a heavy snow case. This is this case where it's one of the earlier idea. Can I see? Can you guys see what's up right now? I see. This is me over here.
I think you jumped ahead 2 slides.
Go ahead. Any questions while we're recovering our situation here? Okay, so sorry about that delay, but let's see. This is another case here with improved. We had the RAP V1 was going to too low, ceiling over East Texas there, a better depiction with MDFR from RAP V2. So another case here looking at improvement. This now is in Cape forecast. It's an overnight situation which over the high plains, some pretty excessive Cape values are showing up over Kansas, over 4,000 joules per kilogram. That was reduced tremendously in RAP V2. And it turns out the key in this case had to do with the way in which we're doing the cloud building from both METARs and settling in a different way in conserving virtual potential temperature. So if we build a cloud, then we'll bring down the temperature in a consistent way. And that actually then resulted in a much better Cape field in the initial conditions for this time from this case from August last summer. So this now next slide here, just kind of doing a recap again on these changes. And so maybe I'll stop here to ask any questions in those case studies, just to try to demonstrate some of these improvements in RAP V2.
Hey Stan, this is Mike from Aberdeen.
Yeah, Mike.
Just have a quick question, and I apologize for my ignorance here, but for the aviation flight rule that you were showing, do you know if that's being pushed over to AWIPS 1, or is that just available online?
So Ed Zoke, my colleague here who keeps in contact, Ed, do you wish to try to, I think that the ceiling grids are going to AWIPS 1, absolutely. And I think that the visibility grids are there too, but I don't think they're used as much. So this particular flight rules is a combination graphic that we do. I don't even know, is that your question? Does AWIPS have a way to convolve seating and visibility, Mike? Is that your question?
Yeah, correct. Yeah, that's what I'm looking at. I'm not sure if that's available through we use the volume browser that I think Dan Baumgart from La Crosse developed. I'm not sure if that's even an available product.
Yeah, I'm not sure it is either. We just thought it would be useful to put it together for us. And, you can see here we're using Greg Thompson's depiction from the surface ops. Yeah, so if you would like us to consider that, this is almost could be an issue for the NAM, too, to get those out there. We could consider adding that still for the HER implementation in July, I'll bet, right now. So is that, Bernard, do you want to comment on that or get some feedback from the field? Is that something the Weather Service would like us to do in the RAP in the future, and even with the HER to have a separate grid for aviation flight rules?
Yeah, I'll make a note of that, Stan, and we'll check into it.
Great. Thanks, Mike. Good question. Any other questions in these case studies?
This is Jeff Manning, Central Region. Have you seen any cases where you would have expected an improvement but didn't get as much as maybe you were hoping for?
Well, I would say that we get humbled still frequently with RAP V2. Those actually have motivated some change. So, don't consider RAP V2 as, it's all over, and boy, we NWP developers. Yeah, actually, I will mention one thing here, which will rear its head once more as we go into the spring, and that is the RAP V2 temperatures over snow cover with warm air advection. So the RAP has been challenged. We made some progress on this coming from the ruck years, but have a situation where, which can help, it can definitely happen. In fact, you could see it in the Sochi Olympics with these people skiing around with 50, temperature in the low 50s Fahrenheit. So you're going to see from RAP V2 also temperatures over solid snow cover capping out in maybe low 40s. We might get to mid 40s, but you're not going to see those temperatures in the 50s and even up into the 60s, which can sometimes occur. So that's one area that we're working on even today. Actually, what would you guys say? I have some colleagues here with me. What are other major glitch areas still in the snow cover in the west? Yeah, so John Brown here's reminding of snow cover in the west we think has been deficient, and we actually just recently discovered kind of the mask, the terrain blocking mask for radar data in the west seems to have an aspect that's not correct, and so that's another area. Oh yeah, okay, here's another good one from Curtis Alexander. So we had a great opportunity to look more at the effect of lake ice cover this year. And what happened over Lake Erie was that even though Lake Erie had some ice cover over the whole lake, a lot of it was fractional. But right now, the ice data set from Snow and Ice Center doesn't have ice fraction in it yet. Well, that makes a difference for fluxes. So then the lake effect snow upstream over northwest PA and western New York, the lake effect snow is deficient from the RAP compared RAP V2 versus V1, sort of for the wrong reason. The RAP V2 is pumping in too much moisture from those too warm LSTs, but so that is something that we hope to be able to get in for next year, ice fraction to start getting in there. So if we have another cold winter, lots of ice cover, then we'll be in a better position to capture the right fluxes from the lakes. There's a couple for you, okay? All right, well, let me, let's see here. I guess we've got a lot of time. So again, this is sort of a recap, and I hope you guys are cooking up some more questions right now. So we're within 5 slides at the end here. So again, these improvements in the data assimilation, they're critical for the larger scale dynamics with this hybrid data assimilation, the way in which we bring in the hydrometeors. That's critical for really getting the 1-hour precip, especially, which then drives the boundary layer, especially in the warm season. These other changes here, these two are especially important in the warm season, but they definitely come into play in the boundary layer structure. Our example from SPC in the Memphis case, that was a Memphis case. As you know, we can have severe weather in the cold season also. This low cloud building is probably year-round improvement here, be able to capture these stratus decks. We've heard some folks from the West Coast seeing that the RAP V2 and the HER, which is driven from that, is been doing pretty well with West Coast stratus and sometimes in stratus in other areas of the country. And then in the model, we've got these improvements in the physics coming in here, which have been pretty critical also. So this next slide here, again, as I wait for it to come up, just a recap and where the actual improvement is and the forecast. So winds especially, both upper air and surface. Moisture, both at upper air and surface. Where it's dry in the RAP V2, actually this is another good thing to add to our glitch areas. You know, when you should maybe have a 15-degree dew point depression, something like that, then the RAP often will look too dry. It may have a 20 or 25-degree dew point depression. So those are, we think, less critical. We'd rather have the right dew point where precipitation and cloudiness is at stake. So, but that is another area we're going to be working on. Precipitation, definitely better, as you saw from our depiction, and then some improvement for sealing. I would say fair, maybe slightly better than a slight improvement for sealing there. And then just doing a recap on our improvement here in RAP V1 versus V2, looking against RAOBS. This is again from this last fall. You can see a pretty good improvement in wind forecast and also in RH. A little bit less so in the temperature forecast. Maybe a similar overall improvement for difference there for RAOP verification. So then to step ahead to where we're heading, we had RAP V1, which was great to get that in, which went in May 2012. RAP V2 has been used to initialize the 2012 and 2013 HERD. That's what's now going in a week from today, running at NCO now. Her version 13, just to look ahead here, that actually is going to be scheduled now for implementation in July 2014, and so we're going to continue to support doing these real-time experimental runs out of SREL through the implementation, and we're using two different research supercomputers to get the reliability there up into the upper 90s. So this next slide here is just a quick look ahead. We do have some improvements already that we're starting to test here toward RAP version 3 and HER version 2, improvements in the data assimilation with physics. And so we anticipate these to get implemented in 2015. And then finally, our sort of overall summary here. We've already went through these changes in RAP V2. And so 2015 RAP V3 and HER V2 improvements, and we'll have to talk to you about those later on. We do look ahead toward this regional ensemble era with the Rapid Refresh Ensemble, the NARI, using both NMMB and ARW cores here around 2017. And so that's going to be a huge step, and then we need to have a HER ensemble maybe around 2019, depending on how the resources go. So I think that's my last slide there, so invite any other questions that you all may have from any of these slides.
I have a question about the aircraft soundings.
Sure.
So at what point does the aircraft sounding, the weight of its data supersede the satellite soundings? Because typically the satellite soundings get worse and worse as you get closer to the ground. So at what level does the aircraft sounding have more
Versus
weight?
satellite sounding, did you say?
Yes.
Yeah, we don't assimilate satellite retrieve soundings. We found that to be too problematic for inversions, and so we absolutely assimilate the radiance information, but to use the retrieve soundings, we found to be problematic, kind of for the reason that you already suspect there.
Okay. How long was the final version of the RAP V2 tested? Was it just, I know you said 2012, 2013, but it looks like a lot of the case studies were from the fall of 2013.
Yeah, I guess that there was one last difference that was modification. We found that there was sort of introducing a bias through the land surface model in September, and so that change got made. It didn't change the overall results, but that was the last one. Before that, we would say about April the 1st, that's when we introduced the ensemble data assimilation to the RAP V2. That was the last big set of changes. We also introduced the MYN and the 9-level boundary layer, land surface scheme. So we would say that what you're getting in this implementation was pretty much largely frozen last April.
Last question, one of the slides said Mesonet data flagged. Does that just mean data that was bad, or are you not using?
We're not using it overall right now. We're doing experiments at this point, and we're finding even with some pretty heavy screening that we're getting some degradation to forecast to the surface in a loft. And we're talking with the NSET folks. They're claiming that they don't get such degradation from use of Mesonet data, but it might be because they used particularly high observation error. So we're trying to use the Mesonet data and maybe have some way to give more credence to the more solid components of the Mesonet data sets that are sort of government supported. There is one issue there that some of you know, is that any mesonet obspec. Most of them are not 10-meter winds, so we don't have a way to identify who's at 10-meter versus 2-meter winds. So that's a big problem there. METARs are 10-meter observations pretty much. So be glad to talk about that to whatever extent you want. So that's where we stand with mesonet. Interesting area.
Okay, thank you.
Jacksonville, Midland, WFO. Was curious about fire weather situations and was wondering if you all had done a comparison on a significant event like the Yarnell fire last June, or if you've not, if you'd consider it.
Yeah, we actually had a very good forecast for a very sad, horrible event from the HRRR for Yarnell. And so using the RAP-V2 initialization, the RAP did a great job in forecasting the convection over the Mogollon Rim, the outflow coming down through that and really getting down to the Yarnell area. So we think that is a good example of how having good boundary layer structure is necessary for having good outflow situations. We did not rerun Yarnell with the RAP-V1 kind of initial conditions, but I can tell you also, I think many of you are aware that the HRRR did a pretty remarkable job with the June 2012 derecho case in the east and really captured the punching of the derecho across the Appalachians into the mid-Atlantic states after dark that evening. We reran the derecho case with the RAP-V1 initial conditions and got a much poorer forecast, even though the rest of the HRRR WRF configuration was the same. So for that case, we know that the improved boundary conditions were critical. So back to your question on fire weather, I guess we would say that it is highly likely that the improved boundary layer structure from RAP-V2 is going to be a better situation for fire forecasting and for the applicability to the HRRR, and that's exactly what's coming in with the HRRR implementation and being initialized from the RAP-V2 with its improved boundary layer structure. Does that answer your question a little bit?
Yes, sir, it does. Thank you.
There's another question there, Jacksonville or something?
Yes, Dan, this is Pete here. I had a question for you on the NAR, which your slide on the screen currently shows implementation in 2017. I just happened to learn this morning, in fact, of the NAR time lag website that looks like it has real-time data. And my question is whether I should encourage our staff to be looking at that now, or is that truly experimental and perhaps wait to this implementation in 2017?
Yeah, you know what, I think that you probably should look at that now. You know, it's a combination, it's a time-lagged ensemble with RAP members that are all about the same time, and there's actually some NAM members that are tossed in there also. So the NARI TL for time lagged, as they call it, I think it's not perfect, but I guess my sense is that that is better than just looking at a single RAP forecast for low-level clouds. I think that if you want to go to convection, I would go to the HRRR, and the HRRR actually has an ensemble, time-lagged ensemble already called the HCPF. There's a link to it off of the HRRR website. So if you want to talk about convection, then the HCPF is the way to go. But for ceiling forecasts, I think that the NARI TL is a good way to go.
Thank you.
You bet.
Could you real quickly just go through the comparison between the RAP and the HRR and how they will evolve over time? Again, I was distracted being here part of the slide that's on the screen.
Yeah. So there we go. This actually describes here in this slide, I hope this is what you wanted to hear, is that the RAP-V2, which we've been using to initialize the HRRR, including right today, is what's going in next week at NCEP. The HRRR which is running right now, is also getting implemented at NCEP. This is the this column here is for the SREL experimental version, and then the NCEP implementation is now scheduled for July. Is what we're running right now. Now there is a further improvement, and that is what's shown in this slide here. So this slide here was sort of a look ahead, because we do anticipate, in fact, we already have pretty very promising changes for the RAP-V3 and HER-V2. So we're going to be running those experimentally at SREL starting over the next month, and those would get into NCEP in 2015. So that's the quick story there. Is that what you wanted to hear about?
Yeah, and then looking further down, at some point, does the RAP just kind of fade away as the HER supersedes it?
That's correct. The RAP would run independently when this NARI goes in. There would be, I think the plan here is to have some NMMP and ARW members who'd be running out here to more the SREF kind of time frame in that, but we wouldn't run the RAP separately when the NARI goes in. Nor would there be a NAM, by the way. So the NAM would kind of come out of the NARI at that point.
Okay, I think I got that.
Yeah, it's sort of in other words, it's sort of going toward more of a pure ensemble framework here for the regional component, kind of combining the short range RAP niche with the medium, up to 2 or 3 day NAM, and kind of putting this together. And the idea being that with the diversity and the dynamic core, this is one place we think that this can be used well to benefit the users, and having the dynamic core diversity to improve the ensemble along with physics diversity. I do want to point out here there's a regional ensemble data assimilation anticipated here as well. So, but yeah, the RAP and the NAM kind of go away at that point. They're the RAP and NAM as you now know it.
Thanks.
You bet.
Any other questions for Stan and his group? Okay, well, as I mentioned, we have recorded this presentation. We'll make that link available to you, as well as also a link to the slide deck, so you can refer to them as well if you want to share with your offices. We'll repeat the webinar on Thursday. And again, next week, regardless if you're AWIPS 1 or AWIPS 2, since the output from NCEP, the computer system, for RAP-V2 is the same parameters on the same grid, that'll be completely transparent. It'll just happen. And then as Stan mentioned, in about July is the plan for the high-res rapid refresh to be implemented operationally at NCEP. And the regions are pushing very hard to get output onto both AWIPS 1 and AWIPS 2 from the high-res rapid refresh as soon as we can after it becomes operational. It won't be the entire model output because it's a 3-kilometer grid, but certainly all the parameters you would need to initialize your grid, plus some additional fields. Jeff Waldstreicher and Eastern Region SSD is sort of leading that effort. We're first looking to collect the list of what all parameters we want as they begin running the model on the experimental computers at NCEP. We'll get an idea for how big those fields are, assess the available bandwidth, and work from there. But a big push to get that output to the field on both AWIPS 1 and AWIPS 2, the high-res rapid refresh, as soon as we can after it becomes operational.
If I can add, just we are really grateful to the field folks who give us feedback. We really depend on that. So Steve Wygant and Curtis Alexander and John Brown and me and Ed Zoke, send us comments as you guys have further suggestions. We really rely on that critically.
Okay, well again, thank you everybody for joining us this afternoon. Thanks to Stan and his group for the presentation.
Thanks. Talk to you soon, Bernard.